PyTorch has emerged as the de facto standard for machine learning and deep learning. And I know a little bit about PyTorch, but I've brought in an expert, Sadaf Zala, to teach us all more about PyTorch. So Sadaf, what is PyTorch?
Hey, Brad. So it's a framework for machine learning and deep learning. And what I mean by that is you can use PyTorch to build your models because it provides you all the building blocks. It provides you all the functionalities to run faster training on that model. And it's an open source project under PyTorch Foundation, which is part of the Linux Foundation. So there's a dynamic community behind the project.
Oh, it's great. So it's got an ecosystem and it's in a foundation. So that means you're going to have open governance and a level playing field. That's wonderful. Well, Sadaf, can you tell me about the key features of PyTorch?
Yeah, sure. That's a great question. So let me just mention the common steps of model training. So first, you need to prep your data, your data set, right, for training. And, ideally, you also want to do it for testing, right? And then, the other steps is you're going to build your model, okay? And you're going to train it. And as I mentioned, you're going to test.
Okay. Yeah. So those look like some pretty straightforward features. Why don't you tell me about the first one? What do you mean by prepping the data?
Right. So, the data sets that you're going to use for your model may be small as you're learning it, but for larger models, these data sets can be huge, 10 petabytes, right? So how do you use this data to train your model and later test it? So PyTorch provides you two things here, data sets and data loader classes that helps you to easily feed this data for your training and testing.
Okay. How does this help me? Does it speed things up?
Well, that's a good question. So, it helps you to download the data to make it accessible for your training and testing. And this data loader, it provides you iterator over this data so that you can use them to train in a batch, right? Because you're not going to just feed one data at a time, right? So you're going to train using the batch sizes that you want. It also provides you other things like shuffling the data. You don't want to just feed the data in an order so that your model, it's only memorizing the data versus it's learning. So this will shuffle for you as well. And it provides other features as well.
Very nice. Well, it also helps you to build models?
Absolutely. So, once you think you're ready with your preparation, right, using PyTorch, because it takes care of all the complexities, the next step would be building the model, right, to define your models. And for that, what you need is layers, because it's a deep learning, it's made of multiple layers. So you need different layers like a linear layer or convolution layer. And there are many others that are provided by PyTorch to you. And there are also, things like, besides layers, there are activation functions that you'll be using to add nonlinearity to your model. That's also provided to you by PyTorch. So you don't have to do anything but just to call those functions.
Okay. What do you mean by nonlinearity?
So in general, when you train the model, it's a mathematical term, right? The linear as well. But it will, if you don't need nonlinearity, you basically just get like a one straight line.
Okay.
And in real life, not everything is just, changing in X will be same as changing, your Y output, right?
Okay.
So it adds you that nonlinearity for you. And the next step would be training. And there, basically, I can talk more on the training side, Brad.
Yeah. So tell me features. What does it do to help you train?
So training will require to use a loss function. And loss function is basically to find out the loss that you're going to have as, when you run this model, like a forward pass, right, from input and you get some output, well, you're not going to have the correct output
every time
magically, right? There's no magic there. So you're going to have lots of parameters in between. You're just going to randomize them in the beginning. You get some output, but then you're going to have a loss function to calculate the loss from the desired output, right?
So
those
you want your model to do and reach a certain expectation, and typically during the training process, that model's falling short, and you're seeing how much it's falling short from where you want it to be.
Exactly. So the loss functions, there are multiple loss functions, and PyTorch provides it to you again. You call them according to your need for the model, right? Once you have the loss function used, right, the next big thing is finding the gradients of this loss with regards to your parameters. So PyTorch provides, the backward propagations for you, or auto grade features, right? That is, by far one of the most popular feature of PyTorch, that it will calculate the gradient for you.
Right. So if we all think back from our calculus days, gradients are this piece that helps you to tweak and get the model the way you want it, and it's got it built in for you.
Exactly. So, once you get the gradient, you basically run the optimizer function just to step over, which is again provided by PyTorch to you. And like you exactly said, you're going to tweak the parameters, you're going to optimize it to reach to a level, in number of iterations, right? So that you basically define those iterations. But the number of iterations, you're going to reach to a level where like, what, that should be enough training. I do like 3 epochs, 5 epochs, right, the iterations. And at that point, you are, ready to test it.
And is that a big deal for these models to have to do testing, or just test once and I'm done, or is it more than that?
Yeah, so the next step would be, from here to the test site, right? You need to test it. Ideally, it's optional, but, as part of testing, PyTorch provides a function called evaluation, right? So you can evaluate your model. And at that point, you're not going to calculate the gradient. You're not going to find the loss function, you basically just do the forward pass, you see what you're getting, right? And if you're happy with it, then you're pretty much ready to use the model. If you're not, then you're going to do the further training. Mm-hmm. And again, these data sets I mentioned earlier, that will be used for training, or be used for test, right? Or like 2 different data sets.
So as part of the testing, I'm getting to decide, hey, is my model good enough? I think I'm ready to go with it.
Pretty much.
Yeah. Now, it all seems a little complicated to me. Is PyTorch really easy to use?
Well, yes, that's one of the best things I love about PyTorch. It's easy to get started, right? It's easy to install. It's easy to, use because it's Pythonic. The Py in PyTorch is for Python, right? So you know how much data scientists love Python.
Absolutely.
PyTorch is in Pythonic, and it's been, easily used by data scientists, or someone, if they don't know Python, they can learn it quickly as well. PyTorch.org provides a lot of good documentations, tutorials, that will help you to get started very quickly. And, it's also flexible. So I mentioned the training earlier, right? You can run training, you can run your PyTorch on CPU, just using the tensor that PyTorch uses as a data structure, right? Multidimensional arrays. They can be run on CPUs. They can be run on GPU. They can, you can do the training on multiple CPU and GPU on a single machines. You can do that on a distributed environment on multiple machines, multiple GPUs. So, and you can, like, say, as part of that, you can just install PyTorch on your laptop and play with it, right? There's also like a mobile development going on to have PyTorch on your mobile devices. So, cool. Yeah, it's pretty easy.
A lot of options.
Yes.
Supports a lot of platforms, GPUs, CPUs. Well, what if I want to be a contributor, son?
Well, that's a great question. Something I love as an contributor myself. So it's actually very easy. PyTorch is part of PyTorch Foundation, as I mentioned. There's a dynamic community behind it, very friendly. Lots of people are going to help you to get started, to contribute, right? As long as you sign the CLA, follow the code of conduct, easy things to do, you are ready to contribute. The community also provides like weekly office hours.
Office hours, that's huge. I can come in as a new person and say, hey, could you help me out, or could you give me an easy first item to work on? I could do that in an office.
Exactly. And, there are things like you can easily find the good first issues, right? You can find the documentation issues to get started with. And you can ask questions in the office hours, through their Slack channels, whatnot.
Yep. And, one of the classic tips is, when you join a new project, ask for a mentor and ask them to put you to work on something, because when they put you to work on something, they're going to be very interested in what you're doing. and they're going to give you timely reviews and answer all your questions. So tell me more about how IBM is contributing to PyTorch.
Yeah, sure. Well, so, IBM is contributing to PyTorch in a big way, like IBM always do. We're using PyTorch, right? So we're going to contribute, help the community, grow the community. And a part of that, we're working on many different things. Something called like FSDP, called fully sharded data parallel. A little advanced topic, but it helps you to shard the model parameters across multiple GPUs, across multiple machines for, a faster training. And for your large models, they may not fit in like a single GPU or CPU, right? So we are contributing there. There's really good blog posts out there. Just search for it, IBM FSDP PyTorch. You will find it quickly. Highly recommend to read it. We also provide improvements in the storage side for training, the compiler optimizations, right? And besides that, benchmarking, test side improvements and documentations. And we have multiple developers working in the community.
Right. So it sounds like there's lots of nice features to help it support those large foundation models, supporting multiple GPUs and running in a distributed fashion, and a lot of work being done for benchmarking so you know how fast things are running, and obviously a lot of work in the documentation to help others get started. That's fabulous.
It's amazing. I'm so glad to be part of the community.
Well, thank you, Sadev. I've learned a lot today. This is fabulous. We hope that you've learned a lot about PyTorch, and we encourage you to come join the community. You're really going to enjoy working on PyTorch and pushing forward with your deep learning and machine learning initiatives. Thanks for watching our video. And don't forget, if you liked it, remember to hit like and subscribe.